another speaker. When this speaker is a speaker who's actually spoken in more than one meetup and also in more than one language. His name is Aitor Artola, and he works at a brand new startup that is called Linyotic, that is based here in the north of Spain, where I'm also located. But like I said, Aitor's been very, very active in our community for the last few months. Like I said, giving multiple talks in different meetups in different countries, and has a really interesting perspective that he's going to share with us today about the questions, the issues that are related to storage. Right? We're talking about data on Kubernetes. So that being said, just a quick reminder, we got lots of stuff going on Twitter. We've got lots of original artwork coming out. We've got great conversations going on in our chat on YouTube and also in Slack. So let's keep this going, all right? Great energy so far. Let's keep it up. Aitor, all yours.
Hi, Bart. Thank you for the introduction. I'll try to prepare everything so I can start sharing my presentation. Just a second. There you go. Everything all right, Bart? You can see the presentation?
Yes. Yep, perfect. Looks great.
Okay. Hello, everybody. My name is Aitor Artola, and today I will try to give you an overview of the different storage systems you can find in Kubernetes and their impact in the performance of the data applications that big data applications you might use. So just to give you some context, we have been working in a platform we call Linyotic, which goal is actually to take big data applications and deploy them in a Kubernetes environment. The whole idea is that with a easy to use web interface, you can actually select the tools you need, and in a matter of minutes, you have everything you need to start your big data project. So in order to handle such a thing, we had to, the platform had to deal with the different applications that are deployed on Kubernetes as they are distributed systems, just making sure that they work in an integrated way. Obviously, monitoring would be another of the points to handle by the platform, and then also the access to these applications from outside Kubernetes, dealing with the load balancers and ingress controllers and certificates. Regarding the connectivity and discovery of the containers, Kubernetes doesn't handle that by itself. It relies on applications that follow the CNR interface, container network interface. So from the applications perspective, one of the things we had to do, from the platform perspective, one of the things we had to do was to apply the proper network policies to make sure that the applications were running in a secure way. But then we had this last point, the last mile, right? The management of storage. Storage is critical for the performance of the applications. So Kubernetes as such doesn't handle that directly. It relies on something called the storage provisioner that follows the CSI interface, the container storage interface. So is the storage provisioner the one that is dealing with the different storage devices you might have available in your environment? So in order to understand how Kubernetes manages storage, I'm going to give you some overview, right? So you will have on one side the Kubernetes operator that will prepare all the storage devices and will deploy the storage provisioner on Kubernetes together with an object called a storage class. This storage class would have a reference to the storage provisioner. On the other side, you have the development of the application where you would take the containers and upload them into a registry. The platform would then create an stateful set object and deploy it on Kubernetes. So this object represents a stateful set application, an application that requires a storage or requires a volume, right? So if you check this brief example of how the YAML would look like, you have there are things like the references to the containers. You have also the resources that would be required for this application, and also the specification of a volume claim, which is the storage that we would like to have, or the volume we would like to have for this application. As you see there is a reference to the storage class that we would like to use to manage the volume associated to this application. Once you deploy this object, Kubernetes will take care of everything. So it will identify from the volume claim specification the storage class. From there, it will get the storage provisioner, which will manage the storage devices. And finally, you will get the persistent volume. This way, you will establish a link between the stateful set, the pod, persistent volume claim, and the persistent volume. So the application has a volume, it can start working properly. Now, the point is that in our platform, as we are dealing with several big data applications, each application might have different workload requirements. So in order to select the right storage solution, you have to make some decisions here. The first one would be the support of the different storage devices that you might need depending on your workload requirements. You have there HDD, SSD, and the newest NVMe. On the other side, the storage type that you will like to have for your application is also important, whether it's block, file, or object. And then there are other second-day operations related features that also will need to be considered when selecting the solution. You have the replication or snapshots capabilities, backup support, theme provisioning, and data locality. If you go to the CNCF webpage, you will find there that there are quite a lot of storage solutions available. Just go to the cloud native storage landscape and you will see there more than 50 solutions. Some of them are proprietary, some of them are open source. So today I don't have enough time to go through all of them. But what I'm going to do is I'm going to give you a brief overview of the 3 different approaches that you might see when choosing one of these solutions, okay? So what I'm going to do is I'm going to start with one of them that I call cloud storage, right? As you know, the public clouds already offer Kubernetes as a service. And with that, they offer their own proprietary CSI storage provisioners. So the way they manage storage is as follows. When you request a persistent volume, what you will get is from the public cloud a disk that will be attached to the node. So this way, the disk will be attached and a volume will be assigned to the application. If the pod that is running in one node is recreated in another one due to an upgrade, for example, well, there will be a process of unmounting the volume from the original node, detaching the disk, and attaching the disk and mounting the volume in the new node. So as you see here, the disk will be following the pod wherever it goes. So this is a good thing regarding performance because you will have data locality. But in this approach, there are also some limitations. So the first one is that the number of disks you can attach to a node is actually limited. And because there is a relation, one-to-one relation between the persistent volume and the disk, well, you might have a limited amount of persistent volumes you might have in that node. So when you reach that limit and there is a new pod that has to be created and that requires a persistent volume, well, it will happen is that you will end up with that pod being in a state pending. Okay, so you will need to act manually on that. When on the other side, another limitation is that when you have a pod moving from one node to another, right? As I said, the disk will be moved, yeah, from the original node to the new one, following this unmount, detach, attach, mount process. Now, the point here is that this process actually takes some time. So if your application or your use case requires to be dynamic and very fast, you need to consider this limitation also, okay? So this would be, there are several solutions that follow this cloud storage, obviously all of them related to the public clouds, right? So I'm going to mention now a second one that is called software-defined storage, or SDS. So this term, software-defined storage, is older than Kubernetes as such, and it's coming from the traditional data centers, okay? So these were solutions that were an alternative to the existing external and centralized SAN NAS systems. And the idea is that it was cheaper and more optimal in the sense of you could use things like commodity hardware, okay? So in order to explain how it works, I'm going to take a very popular solution out there that is based on 2 components, Rook and Ceph, which are open source, by the way. So Rook is a CNCF graduate project, yeah? And one of the things that it does is actually it manages the storage device discovery. So if you attach a new disk to one of the nodes, Rook is able to identify that. And the other main task that it has is actually to orchestrate a storage system. It can handle different storage systems like Cassandra, HFS, or many others, as you can see there. But the one I will be focusing on is going to be Ceph. Ceph, as I said, is a storage system, is the one that does the actual management of the storage. storage. So it can handle, it has replication, but Ceph is much older than Kubernetes. Actually, the first release, I think it was done in 2006. So Rook is the one that integrates Ceph within Kubernetes, okay? And finally, Ceph provides different storage types like block, file, or object. So let's have a look to how it works, right? When you deploy Rook on Kubernetes, it provides the CSI interface, right? And it creates several pods with the Ceph functionality. What Ceph does then is take all the devices, storage devices that are attached to the nodes, and abstracts all of them, creating a unified storage system, a storage pool. You can actually have more than one storage pool, by the way. So the whole idea here is that when you have an application running in one of the nodes and you require storage, right, that storage would be provided from any of the devices or storage devices that are in this pool, regardless of whether that one is in the same node as the application is running or in another node, okay? So with this, you have several things to consider. First, there is no attach-detach process of the disks, which means that in here, you solve the limitations I mentioned regarding the cloud storage. When you assign a volume to one of the applications, the assignment will be very fast. And even when the pod moves from one node to another one, the reassignment of the volume will also be very fast. As it manages a replication, then if there is a failure in one of the nodes or one of the disks, right, you won't be affected. The data will still be available. Okay, so in that sense, is an advantage compared to the cloud storage, but there is also some penalty of performance here. As I mentioned, you might have the application running in one node, and you will have the disk with managing its storage probably in another node. Okay, so here there will be networking involved, which might have some might penalize a bit the performance of your application. Okay, so this is the second kind of solutions you will find when checking the ones that I just mentioned before in this cloud native storage landscape. And I will be finishing with a third one that is called container attached storage, or CAS, right? So in order to explain this one, I will be mentioning a solution, a storage solution called OpenEBS, which is also open source, okay? The first thing to mention here is that open source was built with the containers and Kubernetes in mind. That means that basically it's not something that has been integrated into the Kubernetes, like coming from let's say a traditional data center environment. So what it does is things like the storage device discovery, as Rook does, right? And the way it works is as follows. When you deploy OpenEBS, this one will also provide the CSI interface. And what it will do is actually create a specific storage controller pod for each persistent volume. So with this, what you would achieve is a more granular way of managing your storage. So I think with an example, this could be understood better. So take, for example, Kafka. Kafka has built-in replication capabilities. So Kafka wouldn't require from a storage system to provide any replication. Instead, in order to get the best performance, you would prefer to have something like data locality, which means that the application or Kafka broker would be running in the same node as the storage device where the volume is located. So in that case, for Kafka, you would request OpenEBS to provide a storage controller pod that manages local persistent volumes. On the other hand, you might have other applications that actually require replication. In that case, you would require OpenEBS to provide replication, okay, in a similar way as Ceph, but with the difference that in this case, this replication would be managed with using Kubernetes with things like node affinity, okay? So as you see here, what you can do is you can apply different storage policies depending on the workload requirements you might have. Looking at OpenEBS, you see there that you have different storage controllers or storage engines, like the local volumes and several replicated volume controllers, okay? Jiva, CStore, or MajaStore. So you will find here quite a few solutions, right, that follow this approach. Now, in order to finish, and I know that this has been maybe a lot of information, it has been quite fast, I will just describe some takeaways that we have obtained right from the work we have been doing. So the first one is that in whatever application you want to deploy on Kubernetes, the first thing that you need to understand well is the workload, its workload requirements. That's critical in order to get the best performance. Then, before selecting the solution, you have to consider the storage devices that you would like to handle: HDD, SSD, or NVMe. And then, obviously, the type of storage you would be dealing with, like a block, object, or a file storage. Finally, before finishing, actually, you would be taking the right approach from the three approaches that I just mentioned: cloud storage, software-defined storage, or container-attached storage. And from the solutions that are following this approach, you will need to evaluate the different features they might have for the second-day operations. Okay, so with this, I will finish. Thank you very much for attending. If you want to know more about the work we are doing, you can check our webpage, laniotic.com. And if you want to reach me to, I don't know, share some thoughts about what I explained today, well, you can reach me in the Data on Kubernetes Slack channel whenever you want. Yeah. So with this, I think, Bart, I'll finish my talk, right?
Good.
I hope that was on time.
No, you're perfect. But we got a couple of questions that came in. Is that okay? So great explanation, great outline. In your particular case in Linotic. Oh, thanks for turning my camera on. In your particular case in Linotic, what kind of companies, what kind of industries, what kind of sectors are needing these kind of solutions?
Well, right now, for example, you have many solutions provided like as a service by big public clouds, right? So usually they are proprietary. So you end up in a vendor lock-in situation. So for me, it would be like any company that requires doing some kind of data project, yeah, that instead of building by themselves or deploying by themselves all these tools, right? It would be like using Laniotic in order to have that ready in a moment. So for prototyping and these kind of things is great. And then if you go to, let's say, if you go for production, in that case, you could continue with Laniotic or maybe go in a more specialized deployment that you can do on your own, okay? That would be a little bit the area. If you don't have resources or knowledge, Laniotic can help you out in the whole setup.
Okay, all right. And in designing this platform, were there any particular challenges that you didn't anticipate having this be Kubernetes native?
Well, we had experience already working with Kubernetes, and our background really is not, let's say, DevOps. We are more a data engineering kind of, we have a data engineering kind of profile, right? So let's say that it has been a continuous learning process about the possibilities that we can get from Kubernetes, which actually are quite a lot. So I think this has been the main challenge. All the management of the load balancers, the networking, network policies, and then especially now with the storage, to see all the different options you might have there available and just learning about that. And we continue learning, by the way. I mean, will never end. I think there will be still quite a lot of evolution in this area.
Yeah. But like you said, it's precisely because of that learning that we have a wonderful community of folks such as yourself that are ready to help out and answer questions. So that being said, Aitor, thank you very much. We're getting great feedback here in the YouTube chat. So I think there might be some follow-up items there. Remember, you can ask questions in the YouTube chat. You can also jump into our Slack. You can tag people like Aitor directly, and they will be happy to help you out. So great. I think that's fantastic. So now we can move on to the next speaker. Like I said, we're getting really, really good